Hello again. Today we're going to be talking about different ways of measuring the center of your data. This is lesson 4.4, so let's get started. The first one, we've already talked about this, is the mode. And all the mode is the most frequently occurring value in the list. It shows up the most in the list. And really that doesn't tell you much about the list. It just kind of tells you which data value happened the most, and that's, that could be anywhere in the list, so it really doesn't tell you much about the list itself. So it's not affected by any other values that that occur less frequently. So it's not a good measure. It's valuable if you have other things. The next one is the mean. The mean is the sum of all the values in the list divided by how many numbers are in the list. That's kind of easy to understand. It takes all values into account because you do have to include them all when you're calculating the mean. And any change in that list will have an effect on the mean itself. Then we talk about the median. The median is the middle value in a sorted list of numbers. You have to sort the numbers first, and then you have to find the number that's right in the middle. Now, if there's an even number of numbers, then you're going to have two numbers in the middle, but you still only need one median. So what you're going to do is you're going to take those two middle values and you're going to average them together, and that will be your median. Okay, and again, this only takes the middle values into account, doesn't really say what's going on either side of those median values. All right, so let's look at an example. We've got this list of numbers here. Looks like there are 10 numbers in that list. So the mode is 8 because it shows up 3 times, and that's more than any other number in the list. The mean is 5.5. You add up all the numbers and you get 550 divided by 10 is 5.5. Actually, you get 55 if you add up all the numbers together. You get 55 and divide by 10, you get 5.5. All right, and then the median is also 5.5 because there are two middle numbers. They are 4 and 7. Those two numbers are right in the middle. So I have to add those together and divide by 2, and that will give me 5.5. Okay, so now let's look at a different example. I've got a set of data values and the frequency with which they appear. Again, not really sure what the situation is, but it really doesn't matter. So the number 3 shows up once, the number 4 shows up once, and so on down the table. So there's an easy way to calculate mean in this case. What I'm going to do first is I'm going to, since threes show up once, then I'm going to put the product of each frequency and each x in the last column, and that just saves me from adding the same number a bunch of times. It just saves my calculation, saves me a little bit of time. Okay, and then I'm going to add up the frequencies along with the product in the last column. So that 278 in the bottom right corner, that's the total that I get when I add up all of those numbers that are in the list. The 1 3, the 1 4, the 3 5s that show up, the 7 6s that show up, and so on down the table. I could have added all of those separately, but by multiplying the frequency by the data value, it allows me to calculate that total much quicker. So the mode is 7 since it shows up 15 times. I really didn't need to calculate anything to figure that out. The mean is 6.95 because I take my total, 278, and divide it by the 40 numbers that are in the list. Okay, now finding the median is a little bit of work because I need to figure out where that median is. Well, there's 40 numbers in the list, so the median is going to be between the 20th and the 21st numbers after I sort them. So let's add the frequencies starting at the top, and we're going to figure out where the 20th and the 21st numbers are. Okay, so the 1 plus the 1 is 2. So if I just look at the 3s and the 4s, that's only 2 numbers in the list. Then if I add the 5s to the list, I've got 5 numbers. Then if I add the 6s, and there's 7 of those, if I add those 6s to the list, I have 12 numbers, still not enough to be the 20th and 21st. Then if I add the 7s to the list, I'm up to 27 numbers. So now I've gone past the 20th and the 21st number. So the 20th and the 21st number must be included in those 7s that I added to the list. So the 20th number must be a 7, and the 21st number must be a 7, because that's what I just added to the list. So the median must be 7. which is the average of the 20th number, the 7, and the 21st number, the other 7. The average of 7 and 7 is 7. So the median must be 7. Okay, if I use data classes, this is just another example. I haven't used the same data. I'm just giving you a different set of data to show different ways of calculating mode, mean, and median. So let's say that these are scores on a test and they're sorted into groups. Okay, so 2 people got between 50 and 59, 3 people between 60 and 69, and so on down the table. What I need to do first, since I don't know where those numbers are in that range, I need to make up some value that will represent every grade in that range. And it may not be accurate, but it's really all I can do now because I don't have the individual scores. This is all I have. I have 2 scores between 50 and 59, and I have no idea what they are. So I'm going to find the midpoint of each range. Okay, so 54.5 would be halfway between 50 and 59. 64.5 would be halfway between 60 and 69, and so on down the table. So that's the midpoint, and that's going to represent an approximation of each grade in that data range, even though it's not very accurate. Okay, and again, just like we did with the individual scores, we calculate the product of each row just to make it easier to calculate totals, and then we're going to sum on down the columns. So there's my products. The 54.5 times 2 gives me 109. 3 times 64.5 gives me 193.5, and so on down the table. And then I add those 2 rows. I really don't care about the sum of the midpoints, so I'm not going to calculate that. But I have 25 scores that I need to consider, and the total of those scores is 1,922.5. Okay, so that's the same table. I haven't changed anything, but now let's calculate things. There is the modal class, which we've talked about earlier in this unit. That's the class that has the highest frequency. May not be the grade that has the highest frequency, but it is the range of grades that does have the highest frequency, and that's from 80 to 89. The mean is going to be 76.9 because that's the total, 1,922.5 divided by the total number of grades that I'm considering, and that's 25 grades. Now we need to find the median. Okay? So finding the median, there's 25 values, so I'm interested in the 13th value in the list. Okay, so I'm going to do the same thing with the last table that I had. If I just look at the scores from 50 to 59 and 60 to 69, that's only 5 grades, so I haven't hit the 13th grade in the list yet. If I add 8, now I'm exactly at the 13th grade. So the 13th grade must be somewhere between 70 and 79. So I'm going to just take the median of that. Even though, again, it's not accurate, using classes is the best estimate that I can get. If I wanted to get even better, then I would have data ranges of a smaller width. But really, that's the best I can do for right now. So that's how I'm going to find the median of data ranges and scores that are grouped in data ranges. So kind of a lot to absorb. We did a lot of examples with mode, mean, and median. Maybe watch the video again, pause it, rewind it if you missed something, and if you have questions, let me know, and I will see you tomorrow.